Welcome everyone. So today we're going to be talking about how you put together site plans, and we're going to use this real life example of a large acreage out in the Shawnee area that has a lot of topography change, and we're going to talk about how to read these maps and how to do a site plan of a home on there so it optimizes the design. So as we look at this overall site, a couple things jump out. One is that there's a lot of action going on. There's a ridge line right through here, and then you can tell that there is a creek running through here. Now, interestingly, the difference between ridge lines and creeks, a lot of times you don't know if it's going up or if it's going down. Each contour line, of course, represents a change, in this case of 1 foot. These are 1 foot contours. And so the only way to know if this is a swale or a hilltop is to look at the numbers, other than when you look at creeks and you see these pointed lines like this. These are classic indicators of creeks right through here, whereas rounded areas like this are classic indicators of ridge lines, because unless it looks like a sharp edge on a mountain, it's always going to have a curve, where creeks will have this. So we know, for instance, we've got a pond right here where the ground is sloping from this ridge down to the pond. It then does the overflow here and goes, and this is where the water goes. And water will go down this creek as well, off of this ridge. So now in this particular case, from the main road, the driveway is going to come through here. Notice it kind of essentially follows the ridge line, and we're going to place the home on the ridge here. Now, where the home goes in terms of relation to the ground around it is an art form, and so we're going to try to optimize that today. Over here is the main river. Is that the Kansas River? Kansas River. So we got a beautiful view this way, so we're kind of thinking about views this way. And you see a massive drop that's over 110 feet down to the river. So this is really up on a high perch. So what we did is we zoomed in on that particular area. So that is that hilltop. And we have this home designed at the exact scale as these contours. And so we're going to start talking about from scratch, how do we decide where this goes? Okay, so the first thing is, and this is 20 scale, is that right? Okay. The first thing is, because we're going for views down to the river this direction, I kind of like the back of the home with the pool area. So give you a quick idea of this plan. Here's the garage, driveway coming around, circular driveway in front, front door, back door, pool area. And typically you're going to want the pool area to be at the same elevation at the home. So this really makes a challenge in that basically all of this needs to be at the same elevation, even though the ground is doing all kinds of different things all the way around it. And again, this could be tilted like this to look straight down the hill, could be going the other way, but essentially we're looking to have the back end go down to the river. Now you could argue that you could pull this over more on, put the home right in the middle of the hilltop, but then the driveway, which also has to stay flat, is now would need massive retaining walls over here, even though you're minimizing a retaining wall here. So it's always a fine line between optimizing, one of the two sides of the house. But I think what would look best is if you're out here at the pool and you're looking straight down the hill, it'll feel very natural. I think if you're over here, it's going to be like the hill's kind of wrapping around that. So I'm erring on this side right here. And then again, the idea is you want to try to put the home where you're putting the majority of the flat area right on top of the crest. So there is the crest of the hill. This is, give you an idea of the contour lines, this is 939. So right here in the middle, you can just assume is about a 940, right? So we're going to say that the middle of this whole thing, which all of this needs to be relatively flat, is kind of coming right through there. So I'm going to put that there. The other thing is the driveway is most likely coming in right through here. And about a 12-foot wide driveway is what we're going to figure. So that's a 20 scale. So there's roughly 20. So here's a driveway coming in. This does not need to be perfect, but that's where it's coming in. We'd like the driveway to hit right dead on that circle right there. So that kind of puts us back a little here, like so. Notice I'm going parallel. We'll put the circle right dead in the middle. So this driveway can now come in here and then blend into the circle like this, like that. Now the best way to do that is just put some tape on this guy, and then we can start designing. This is the old school way, of course. Let's see, so right there, angle that. Again, there really is no right or wrong way. It's just a matter of what looks best. Say right about there. Okay. Now, the first thing to do is to figure out where the top of the foundation wall is going to be, because that is really what drives all of the other dimensions of this and how it sits in relation to the ground around it. Does someone have a piece of paper? Maybe I can just, can you see this over here, Demi? Okay, so I'm just going to make some notes over here. So we had looked at this earlier, but basically the foundation wall, here's the foundation wall top coming over. There's going to be a plate on top. And for this particular home, we have top cord bare trusses. Double, yep. So in top cord bare, you always have two 2x4s coming across like this. And the truss, our trusses are going to sit down inside of the wall. So the truss kind of goes off like that. So we've got a basically 1.5, 1.5, 1.5. We're then going to use 1.125 subfloor. Then 3/4 inch hardwood is kind of what you figure. And I think when you add all this up, we did this before. Remember, was it this dimension is, let's see, 3, 4.5, 5, so 6, maybe 6.25, I think something like that. And even if it's just 6 3/8, that's what it was. Yeah, 6 3/8. Pretty close to 6 inches, which is basically 0.5 of a foot. We're going to do everything in terms of feet. Now, when we say top of foundation, TF, we're talking about the elevation at that spot right there, right? And then finished floor, FF, is right there, which we're going to say is 0.5 feet higher than that top of foundation. Because there's no walkout on the back of this basement, we don't really have to worry about how deep the basement is or what that elevation would be, because it just doesn't come into play. But if there was a walkout, then we'd be looking at BF, or where the basement floor is. So, okay. So then what we do is we say, all right, the top of foundation. Now, as we're pulling in this driveway, what I think about is, okay, what are you going to see? Someone coming in is basically going to be hitting roughly about here, about a 940. So, for instance, you wouldn't want this house at like a 935, because then it'd look like it was down in the hole, right? So, and you wouldn't want it at a 950, because then it'd just be ridiculously high out of the ground. So, you know, those two are out. A 2 or 3 foot rise from the pinnacle is probably a pretty good idea. So this could be, say, a 942, and it'd be 2 feet above that area. So I'm gonna just go with it, and then later on we can come back and change it. So that means the top of foundation is equal to a 942. Okay. Then that will set everything else. So then you start looking at the front door of the home, right? And usually you would have a step down there. So that's a 941.5. And then maybe a 6-inch fall all the way to the front. So that's a 941. And then basically you're going to have, we've got 3 steps shown here. So that'll be at the bottom here, 941, a 939.5. And so, let's see, 941. Yeah, okay. And we may not even need to have that, because we could probably just have a few steps down. Let's just call that it could be 2. So let's call that a 940 right there. Figuring 6-inch steps, even though they're really going to be 7 7/8, something like that. Again, it doesn't have to be exact. So that puts the 940 contour right there. Now we know out the back of the home that this is going to also be a 941.5 right there out of this door, right? And then you've got this door right here where we've got it stepping down, but it doesn't even necessarily have to do that. But we'll say there's a step right here. We'll just call it. It doesn't step down. It doesn't. Okay, so we'll say 941.5. And so we look at where these are going to be. Now, the way we do our garages, we bring our garages right equal to the finished floor. So that means our garage floor is going to be a 942.5, because we're going to go to the finished floor. Or you're going to have a step down into the garage?
It's going to have a step down at the breezeway and a step down at the garage.
That's right. Okay, we're having 2 step downs. Okay, so your finished floor in this house is a 942.5 because we're up that 6 inches. But then we have a step down right there, so it's a 942. And then we have another one, so that makes that a 941.5 as we go into the garage. Then you always want to fall, big garage, maybe allow 6 inches drop. So that puts it at a 941 right at the front of the garage. So, okay, so we now know, and by the way, this garage, because they're always flat, it's 941 all the way across the front. You've got a door here, that's a 942, and another door going outside, so we'll call this a 941.5. So we're establishing where the heights are everywhere. Okay, now, if it's a 941.5 right here, you're probably going to go down to a 941 out here. That means the pool, we got to set what the pool elevation would be. So let's see, we want to keep dropping. And this is for a pool, you're going to have a drain right here because pools have to drain downward. So we could maybe make that a 940.5 at the pool drain. So we're going to go back up to a 941. So we can have the edge of the pool be a 941, which is a foot below the top of foundation of the house. So water coming out of the pool could never go into the house. Okay. And then if that pool edge is a 941 there, it means it's also a 941 there, 941 there, all the way around. It has to be the same. Now this can go down and drain straight out. So we could have a 940.5 right there. And this is a little longer. So that's probably a 940 right there. So, and if we go 941.5, probably 941 right in that area. So, okay. So now what we want to do is start drawing contours. So the 941 is actually on this line right here. And we know it comes through right under the deck as well. So that means here's your 941. That basically, well, actually, let's see. That'll have to drop a little bit. So you have a door right here going out to the front. So a couple step downs there. So let's, in fact, probably just want to do one step. So we'll do a 941.5. And you always have to think about any of these site plans, like where does a dropper of water go? Like you have to get a drop of water out from every spot. And the toughest spots are these courtyards because the water has to come out and then go around. So that's a 941.5. That's as you come down that step. That means this is probably similar to here, 941.5. And key dimensions too are whenever something is going to drain, for grass, the minimum slope to drain water is 2%. For concrete, the minimum slope is 1.5%. Some people would say 1, but I think it'll make too many bird baths where water just stays. And then your max slope for mowable grass is a 3-to-1, and a desirable grass to mow and not kind of be on the edge is 4-to-1. So you got your minimums and your maximums. So here we kind of have a grassy area, so you want that to be a 2% slope. So the water that hits this corner or this corner is going to have to drain out to this spot. And if that spot is 25 feet, let's call it 30 feet. So it's 30 feet, and slope equals rise over run. So if we're going 30 feet, and we're going to say it's got to be 0.02 for the rise. So we're determining how far that is got to drop from there. So it's going to be 30 times 0.02. And anybody do that? Christian, you got that? Those 30 feet times 0.02 equals 0.6, okay? 0.6, so that's really at least 6 inches. So what we'll do is we'll just make this a foot drop just to make it dang sure the water gets out of there. So that means that point right there has to be a 940.5, right? I didn't go short, I went more to make sure it gets out, so that the water here is greater than a 2% slope. So that spot has to be that or lower, or water will get stuck in this courtyard, right? So that sets that. So now we know this is a 940.5 and that's a 941.5, right? That means the 941 comes through right here, right? That contour line. So now I'm going to make that contour line go like this. And notice I put these little hooks on it, right? The contour line. What that means is that little hook shows that the water is sloping away from the building. You don't want the water to be running straight next to the building because then it can go back in. So this little hook indicates that it's sloping this way. The water is actually going like this. And feel free to draw as many arrows as you want all over. So the water is now coming to this spot is where it's going, all right? Now, the 941 is right at that spot. So that means that contour line is like right on the building, right? So this building line, if I'm going to draw the 941, looks just like this, right on the building's edge, right? All the way, in fact, probably just all the way around. That's where it goes. And then you have a 941.5, so it actually kind of comes back here. So you can't really see that contour because it's in the building, okay? So now you want to look at, you got to get the water to drain out this way, again, at a 2% slope minimum. And we don't want this to be too much because then it'd be like if you want to play basketball in your driveway, like that's going to be a drag. So what that means is now we want to say, where do I make that next contour line? If it's 941, where do I put the 940, right? So then you're saying, well, how far? That's really the run, right? So the run is equal to the rise divided by the slope. So now we're going to say that's, so what is that run? So it's 1 foot divided by 0.02. So what's that? I believe that's 50 feet, right? Pretty sure it's 50 feet.
Yeah.
So 50 feet, though, would be all the way out here, right, at a 20 scale. And to me, that's just like, wow, that's way out there, right? You know, to have it be that flat. So, and 2% is pretty flat. So we could make it that flat, but I don't know if we'd want to because you got to think about it. It's starting to go downhill. So, you know, maybe we make it a 3% slope. So if it was a 3%, what's 1 divided by 0.03?
33.
33. So here's 30. That just feels better to me, to have it just be slightly more than the minimum, but not too bad because I want a nice flat driveway. So here's 33 feet, and this is what I mean. It's 33 feet from there to this spot, right? So now we draw that 40-foot contour. What we're saying is there is now a 3% slope on this driveway, which is nice and comfortable. Now we'll see what happens over here to see if that makes sense, or if where I get just so far off the hill or something, it just seems dumb. But I can already see this contour is a 339, or is that a 6? 336. So it's like 4 feet above. We'll see if we got to chase that too far. You'll see what I mean by chasing contours, like how that happens. But for now, we'll just put that right there. Okay, now on the front of the house, you got the same thing. You come out this 33 feet and you have a nice flat, but I don't know, that almost seems like a little too much to me. It's going to be like too flat right there. So let's go say 4% on that. So Christian, what's that? Is 4%, must be 25 feet. Okay, so there's 25 feet. So that's going to set, so we're going to do this. We'll just see how this works. But the main reason we're doing this in pencil is to just see how it works. So this is the 940 line. And just so you can remember, like you usually put a 940 right there. Okay, so all right, so I got a 941 house. There's my 940. Now we also notice, see, the 940 is all the way up by the house right there, right? So that means this guy has got to come in and attach. By the way, the contours always have to meet. They can never end because that would be physically impossible. So it has to connect. It's like a Tetris game or a puzzle game. So I'm going to make it, I'm going to kind of slope it like that. So there's that flat area that comes over there, right? Now we also know that we have 940 all the way over here, which means the 940 or 941, sorry, over here, which means the 940 needs to be down the hill. And there we already know that corner is at 940, right? So I'm going to say, I'm going to bring that 940 line here, and I'm just going to bring that around. And I don't know if this is going to work or not, but we'll just see what happens. So there's 940. So right now the 940 goes into the wall. And because that's a 941 to a 940.5, the 940 is in that wall. Comes off. Now let's figure out here. Now again, we got to slope a minimum of 2%. And we know that this distance, let's see, from here, from this door, a drop of water that lands there is going to want to go all the way across, okay? So, and that's a 941.5. Let's just see what that slope would be. If we made this a 940.5, let's double check that that's going to work. So that's a 941.5, 94. So that's a 1 foot drop, and that is in 70 feet. So what's that slope? So do 1 divided by 70.
Just barely.
Less than 2. So what we know is that drop of water is not going to work, right? It's going to get stuck in the middle, and you're going to have like a pond right there, right? So now we know we got to do something else. Like that's not going to work. So, but you also got to be careful because that's a 940. You don't want this to get too steep, right? So now it's like, okay, this drop of water, what's it going to do? Well, we can also carry it out this way, right? Because this pool is setting, like this pool is kind of locked in, and we don't really want to jack with that. And we don't want to make the slope around the pool be too much because you'd be sunbathing and you'd feel like you're falling off the edge. Okay, so now what that means is we got to bring this down over here. So I'm going to lower this area. Let's just say we start going 2% this way. So, and we got to get around this building. So really it's going to go 45 feet. So Christian, if we want to see, we're looking for the run. So let's go, let's see, the rise. Well, no, let's see, we're going to look for, yeah, how far it's going to drop, I guess. So we're looking for the rise. It'll be 45 feet times, yeah, 0.02. So about 1 foot. Okay, so that means this guy has got to be a 940 over here. So now we know a drop of water that lands there, if this is at 940, is going to make it at 2% going this way. So it's kind of water going that way, and it's going to go this way. And this is a 941 at the corner here. And we're less than that. Yeah, we're less than 50. So this could be a 940 over here too. So water can go this way. We'll make it a 940. So now water will go this way. So now what will happen is this water is going to come out, and it's actually going to go like this, right? And if we look at that distance, yeah, it's 50 feet, and it's 1.5 feet. So in 1.5 feet, it'll go like this. It is raised or isn't?
Yeah.
Yeah.
Has 2 steps.
2 steps. Okay. So, but I'm thinking this drop of water is going to come like that. It has to come off this too. So that means if we keep this the same slope going down, well, let's see. If this is 20, 23. So let's just assume that's going to go straight down. So, Christian, what's a drop 22 feet at a 2% slope? What is that drop? So 22 times 0.02. Oh, okay, so let's make it 6 inches, go a little bit more than that. So we're going to go 941 right there. Okay. Now in commercial projects, by the way, you got to get down to the much more detail, like inches. Here we're just going like 6-inch increments because it's just not as critical. But in commercial, because of ADA and things like that, it's got to be spot on. Okay, so you're actually at 941 right there. So it's going to slope 2% to that edge. And that means that'll be a 941 as well. We'll just keep it single sloping. So the water is actually going to run off that. And that's a patio of some kind right there. Raised patio. Okay. So it's going to be a 6-inch drop straight across to a 941, which means we'll make that a 941. So really all the water is just going to go this way. Okay. Then from this 941, now does it drop? Does this patio drop like right there?
Yeah.
Okay. 2 steps or 1 step, or does it matter?
I have 2 steps in there right now, but it doesn't have to.
Gotcha. I'd rather it be 1 just so we don't create a low spot. So we make that 1. This also is where it comes in the architecture, right, of like how many steps you put at different places, because it all depends on what you're trying to drain. So that means the bottom of this 1 step will be a 940.5. which is, you got to be a little tricky there or careful, because you got to make sure everything is not like ponding right there. So that means we probably got to lower this guy a little bit, because that is more than 20, that's 35 feet. So I really want to make this here a 939.5 to do a 1 foot drop. So I want to make sure the water gets out of here. So now what will happen is this just went from 2% to probably 3% as it goes to this 939.5. But now the water off of this patio is going to run like this. This is going to come down and go like this. So now I got everything going away. And again, from the pool, just so you see, it's going to go both ways, from the house to that drain and from the pool to the drain, like that. And then this water starts turning and going this way. This water comes over to this side. So the retaining wall is going to actually go up just a little bit, and then right there in the middle, and then drop back down and drop here. So, okay, so now this garage has to be a 941. So, and that's a 935. So we got to start getting down to that point. So it looks like this is going to be the low point where things go off, because you got to have a 941 right at that door, right at that spot where the driveway is. And then it can start coming down. So now we can have a 940 contour that, let's see, would look something like, let's see, we've got 941. So now your 941 is right in this wall. So there's the 941. Oh, that's interesting. It's funny how these things come together. So the garage wall is a 941, and that's the exact height of the edge of that patio, right? So that's perfect. So the 941 is actually in the edge of this patio, in this wall all the way through. It's just an even 941 all the way across. So that worked out really well. In fact, so is that a 941? So the 941 is just carrying right on the edge of the house. Perfect, that way that worked out. So now you got to draw the 940 contour. And we could say we keep it consistent. It goes from a 941 to a 939.5. So that is a foot and a half, right? Which means the 940 should be about 2/3 of the way over. So right there is probably the 940. So that is the line there. And we want, let's see, so this is a 940 line. So that's 941, 941.5. So what that means is it's going to go something like, let's see, 941. This is where it gets tricky, because you have to show where the lines go. Let's see. So the 940 is in that wall. It's in that wall. It's right in this wall. So it's in this wall. It's going to do something like this. Let's see. It's going to come around, and then you got to hook it like this so that the water comes out. Then this is going to be here. Okay, we get that, right? So now as the water is coming down, it's going to go into this drainage area and then out like this. Same thing here. It's going to go this way to the 940, and we pull it in like this so that water that gets blown in under, I know that's a covered roof, right? But it's outside. So water could get blown into here. And so there's going to be a high point right here where the water underneath actually will go this way, and it'll go this way into these two swales that pull it on both sides. So this spot right there is going to be a 939.5. And let's see, I guess, oh, you know what? I just moved it over. I'm going to pull that here, and that'll be a 939.5 right there. So now that's the two low spots. So everything over on this side will drain here. Now, notice how flat this is, right? If this is not done correctly and we don't allow for all these little 6-inch drops, there will be water hanging in all these places. So it is actually harder to do this spot where it's flat, because you've got to make sure that drainage is always working. This is way harder than anything over here, because this is just going to shed off like crazy. So, but every drop of water now will be going more than a 2% slope. Now, we just kind of winged this, and I'd like to double check all the spots. You know, you want to look at where's the drop of water going to go. By the way, yeah, that drains a 940.5. So So what also happens, notice, is these two low spots on this whole deal. Say it just had a hellacious rain and this whole thing started filling up with water, and then always allow for the drain to plug. So if the drain plugs, the water is going to go up and it's going to go whoop, right through these two 93.5s, right? So this is the overflow swale of the whole deal. Some water will go this way to the 940, but over here where there's further to go, it'll go right there. That makes sense? Okay. Now, that is a 940, that line right there, and this is where you should go ahead and put it in there so you can see it. So there's a 940, and that's a 940 as well. I like to put it on the line so you just know that's the traditional way of showing it. Most of the time too, these contours right here should actually be dashed. That's kind of the official way of doing it, but that's okay. We just didn't have that handy here. Okay, now the 940 line also, we got to think about, is also crossing into here because it's 941. I guess the 940 is there, 940.5 to 940, 941. No, I think that's it right there. If this line is 940, or 941 is right on the house, and then that's a 940.5. So really, these are the only two 940 lines I see, and there's a 940 there. So yeah, so the 940s all connect at different places. So in fact, actually, now I think about, see how these all like don't connect to somewhere else? So this guy now, I see, this is how you know you got it right, is it comes around right here to there. So there's that 940 coming up, sweeping. Now, it dies into this wall. It then stays on this retaining wall right here. It then goes to here. It then rolls around. The 940 is now in the wall all the way over, and it picks up there. So there we go. So there's the 940 that goes all the way around. So now we know we have an island that's at 940. Then it goes up to 941, which we designated as in the wall of the house, right? Then the foundation right there is a 942. So the whole idea is where, you know, the top of the wall where water, you don't want water to ever get to the point. And by the way, where this foundation is, I should show this a little better. This is an important concept here. Top of foundation is right here, and the ground will always be here, right? So the grade is always, we say 6 to 8 inches below, but I like to use 6 again because it just equals that 0.5 without getting too carried away on too many decimal points on this. But this is the ground, right? So the top of foundation here is at a 942, and we have 941 and 940. So we're basically, where that line is, we're 2 feet below the top of the wall to just really make sure water never, ever, ever gets up over that wall, right? So now we have this island all the way up, and now we look at, now we've established that, and we've established that all of these areas are going to drain at a minimum of 2% slope in all spots. Okay, what happens to the rest of the site? Okay, so now we start connecting into other contours. So here's a 939 coming across, and I like that it still goes downhill from the 940. So let's just make this 939. Actually, that was the driveway. There's 939. Here's 939. So now what's going to happen is we're going to start getting into spots where it's going to be too steep, right? And so the desirable slope we know is 4 to 1. 3 to 1, you can get a mower on it, but you're going to feel like you're about falling over. So 4 to 1 is where you want to be. So that means if these are 1 foot contours on a 20 scale, we want to make sure these lines, you always got to think vertically and horizontally with all these lines, right? That means the lines themselves should be 4 feet apart to maintain that mowable distance. So if I take 4 feet from this line, that's right there. So I know now that as long as I stay 4 feet away, and again, it doesn't need to be perfect, that is a mowable piece of ground. Okay, so I'm going to now take this 939, which is right here, and I'm going to swing it like this. And again, what that indicates, right, is that water always goes perpendicular to these lines. So now you're saying the water drop that lands right there is going to go this way, right? And because this is 4 feet apart, that's a 4-to-1 slope right there. So that is a mobile piece of ground. But if you look at this, that contour, oh, you can't really see it. And this is, by the way, where you should kind of rewrite all the dimensions as you start doing this. So, or I'm sorry, elevations, 928, 929, 930. So I know that this is a 930. This makes this a 931, 932. This should look messy. A good site plan should look horribly messy by the end. And then what you do is you draw in with different colors and markers and stuff to like get it, and then you put it on a computer, and then you can make it look real pretty. So 934, 935, 36, 937, 938, 939. By the way, does anybody know why these are like 900, this random dimension of 940 instead of like 100?
It's from sea level.
From sea level, right. So that's the sea level dimension. Now, what I've also seen a lot of people do on these is they kind of, because honestly it doesn't matter, you could just pick one and call it 100 and then just go up or down and it still would look the same. It's just this happens to be accurate with sea level, but you don't have to do it that way. Or sometimes people say the top of the foundation is 100 and then you work from the top of the foundation, which is kind of handy because then you could, look at everything in relation to the top of foundation. Or even better is you go to the bottom of footing because that's where they actually dig the hole. So you could dig the bottom of the hole and then everything goes off of where the hole was dug. So it all just depends on how you like to look at it. But if you got a survey crew, you can just go by the actual feet above sea level. Okay, so now if you look at this, and we know, by the way, just to make it easy, right, is put a 939 and put a 940 on here just so you can follow it more easily. Okay, that's a 933, which means there's a 6-foot drop right now from there to there. Okay, so that's and the other thing is you can see trees that are right here. So anytime you're making elevations go across a tree, that means that tree has to go. So that's another reason why we might finish this and then change this. Like we might say, I don't want to lose these trees, and so I'm going to make this a 3-to-1 instead of a 4-to-1. And so you adjust. So it's kind of like you do a first pass and then you go back and think about it, and then you probably do another pass based on that. Because if it was 3-to-1, it'd just be a little bit closer, and you're going to see what happens there. But for now, let's just go with the 4-to-1. So that means the next one is also going to be 4 feet away. Just mark a bunch of 4-footers. Then another 4 feet. 1, 2, 3, 4. Another 4 feet. There's a 938. And that is going to attach into this one. Again, you want it pulling away from the house, always. 937. Attach into this one. 936. Attach into this one. I'm just going to do it roughly for around 935. 934. And then here's the 933. So, and then that's how much dirt we'd have to move. So I'm going to carry this around. Now, this retaining wall is designed to basically allow like the ground to just drop behind it. So I'm gonna start swinging these guys in. So I'm gonna say this guy comes like this, and then a 938 comes around and just dies in. And again, we don't really care when it dies in at the end. These can be steeper because heck, it's a retaining wall anyway. And so like you're not worrying about mowing anything down there. Next one comes in. I didn't really show that properly. It's going to come around the horn. So these are going to be real steep like that. 936. And anytime those lines get skinnier, it's actually getting steeper. Okay, so we started realizing as we were drawing a whole bunch of lines around here that we were chasing the lines forever. So in other words, it didn't work to put a mowable slope this way because it would just keep going on and on down the hill and we'd be taking out all these trees. So now we're going to kind of go to a different plan. And the idea is to have the ability to walk around the house and get to this spot right here, but then not have it go down the hill. So what that means is a retaining wall probably something like, and this is where you can try out different types of retaining walls, but one that looks something like this, I think is going to do the trick, and we'll see why. The contours never lie. It's the beautiful thing about doing this, is you'll always know. So if we add a retaining wall like that, the 940 can now come around here like this and go right to there. And so now you can easily walk around the house and make that a little nicer line. Yeah, in fact, actually that's open space right there. So we can keep forgetting I can cross over where that area is there. So basically now we're going to have the ability to walk around the house to get to that spot, that door in the back area, which I think would be nice. And then we'll probably make one more contour, be the little bit sloped but not bad, and that's going to catch the end of this retaining wall right here. So again, that's mobile. That's about a 4-to-1 to get to the 939. And then what we're going to do is have these other contours come, and we're going to just say, because we know it's not going to work real well, we're going to go to a 3-to-1 slope, which is mobile but not awesome, just because we're fighting the slope here. So it's about that far. So that much distance right there. So we're going to have that hook to catch that wall. And then that's going to be the 938, 937. It's going to be right there. Going to dive in. 936. So now I'm putting these lines much closer together. So that represents, we know that that's going to be steeper. 935. We have to get to a point where we don't cross a line. 934, 933, 932. Now we're getting close because 932 almost made it but didn't quite. And now 931 just hits the wall. So now we just massively reduced the amount of grading we have to do over there because we made it steeper and we added this retaining wall right here, which kind of allowed us to get into this spot. So now we have a walk path around the house, but other than that, it drops off pretty steep. Now, we may decide later that that's just too much, like we want it to be flatter over there, in which case we'd have to bring a retaining wall out to capture it. But we now saved a whole bunch of trees. 1, 2, 3, 4, 5, 6, 7 trees we just saved because we did not grade it. So again, if the existing contour is there, it means we're not touching the ground. Any of the new contours we have, that means we're touching. So now we got this area to work out. Because we have a retaining wall back here, we don't have to touch any of these trees or grade or anything. So now we have over here now this 940 goes to the edge of retaining wall, but then it's going to drop on the retaining wall down to what's below it. So now we look at how high is this retaining wall. Well, this is a 940 wall. This is 9 foot back here, 10 foot, and that's a 929. So that's 11 foot. So it's an 11 foot high wall across the back. Becomes a 10 foot high wall here, 9 foot, 8 foot, 7 foot, 6 foot. Okay, now let's see what's happening here. So now we got a 940, but that's a 934, so it's still a 6 foot drop. So what that means is this retaining wall is actually going to have to come like this around. Otherwise, we're going to have to come too far down the hill. So now by making this retaining wall this way, we can have, let's see, a 940. So that's a 935. So that's a 5 foot wall. And then actually what this means is this retaining wall needs to come around the driveway, right? So as we're looking at this, we may go, okay, we want to maybe do something different because we're going to be building some big retaining walls. So now to get this okay, but it does tell me now I don't want the driveway that flat because we're fighting this giant retaining wall over here, which is, still 4 foot right here. So if we steepen up the driveway to lessen the retaining wall, but I don't know, maybe what it does is it just makes the retaining wall 1 foot lower, but then you got a steeper driveway. If I were them, I'd probably still want the flatter driveway and just have 1 foot high retaining wall. So you got to kind of think about that. So what that means is this is a 940 contour. So that means this wall now comes like this and comes around this driveway, right? And then the 940 does not come down here because that's crossing over the retaining wall. Retaining walls are wonderful to make grades work. It's just they are costly. So now the 940 is in the retaining wall, and then it comes out of the retaining wall right there. Okay, and then and this is a 936 down here. So we still, okay, so we're still, this driveway swings this far over. That's going to be tough, right? Because that's like a 7 foot. If this was a 939 even right here, that would mean this would be a 7 foot high retaining wall here. So we're kind of getting to the point where we're getting like a ridiculous amount of retaining walls, right? As we go all the way around. So what that means is we need to either look at lowering this or kind of altering, how we put it, because of this. So, but it's a good first pass just to think about. So now the other thing I would say is we want to start making this slope greater coming down from the house. And so if we do that, now what that means is this is going to drop, like the driveway is going to drop. You're going to be here, go downhill, and then back up, which might be all right, though, to save on retaining walls. I don't know, it's a big deal. All right, so now what we did is we pulled the 940 contour closer to the house instead of being out here. So now we're going to try to ramp this down to avoid a big retaining wall there. So we're going to have a flat driveway. Maybe I'm going to bring the 939. Here's the retaining wall, kind of right to that edge of the retaining wall. So 939 kind of right there. Again, you don't want this to get too steep right here, right? Because this is your driveway now. And so the steepest driveway you really want is probably an 8% driveway, right? Anything more than that is going to be just too steep. So if it's 8%, the question is how much run is there in between? So Christian, why don't you give us a 1 foot divided by 0.08? So what that means is these lines, this is really where it comes into play, cannot be closer than 12.5 feet away from each other, or that means that the slope will be greater than 8%. So that means for this driveway, 12.5 is kind of out there a bit. It's like here. So really that's the closest we can put those lines. So that's it. That's the closest it can be, which means this line will then come over here into the retaining wall. And then that's an 8% slope. Now here, we go back over here and we've got a 940 just in that one spot. And here's the 939. Let's call this a 940 as well. And you can do this because we're going to have the grade, the water is going to be sloping like this direction. Right? And that'll be the high spot. Now that'd be kind of neat, I think, right? Because you can do a statue or something in the middle of the island, landscaping or something. It'll be at the high point with the home behind it 2 feet higher. So as you pull up, this is going to look really good. Always think about how is this going to look. So it's going to be pretty flat. And then you're going to look up at a nice island and then the home behind it. So, okay, so that means this 939, well, let's see, it's going to come through here. And I want it to kind of swoop a little bit. And then it's going to join with this guy right here. Now again, 8% down is all we can do. So that's about there. So that means the 938 has to go there. Here's the 938. And we know that has to be 12% at least, 12 feet. And really, you don't really want this driveway. You kind of want the roundabout to be pretty flat. So I'm probably going to bring the 938 around that. And then come across this 938 there. Same thing with 937. It can really just kind of come through here is where it can go like that, right? So there's a 937, which now has to come down, and we'll make this a 3-to-1 so we can get that close. I'm going to bring this down. That'll be the 937. And 937 is all the way back up there, so we got to tie that in the retaining wall. See, 938 has to tie in first, and 937. Yeah, so this 939 is not there anymore. 937 to there. 936, again, once those lines cross, it doesn't work anymore. So that's, we're going to hook that around the edge of the driveway. 936. 935. Again, now as you look down this area, you're going to see this drop off, right? So this is dropping off. But still mowable, right? Because it's 3-to-1, so it's still mowable. Now here, this is good news, we caught it, right? So now we caught the contour on the other side. 934, because these lines cross, we're still chasing it a bit. Now we could put a retaining wall here, but because I can see this is going to happen in about 3 or 4 lines, like I don't know if we need one right there. There's the 934, 933, right to there, 932, we almost made it, and that's it. And the 931 stays. Now there could be a retaining wall on the edge of this driveway to avoid this little area, but you can see now we need a retaining wall all the way from here, all the way around to there, and then you can see where the slope has changed. And that is a completed site plan. So now what you want to look at is, okay, do we like this, right? What are the pros and cons of this site plan, okay? So this is just one way of doing it. So I think it's going to be a beautiful drive. You're coming up, you know, it's pretty flat. You're going to see the island. You're going to see the home, real majestic. It's going to slope away as you look this way. It slopes away this way. Again, these are pretty views, lots of trees and everything. So I think this is going to be a pretty spectacular view, right? When you go to the back, you're going to be overlooking, you know, 6-foot to 11-foot wall out into the trees in the river. So I think this is going to be a pretty spectacular site. The only downside of this is the cost of the retaining wall all the way around, right? That's the negative. So I think in terms of how this looks, it's going to be awesome. It's just, what does that cost? Now, they were clearly planning on this retaining wall in the back anyway, right? So a little extra retaining wall that goes from 6 foot to 5 foot. This isn't really that bad. The other thing is, think about retaining walls. 4 foot high, 5 foot high retaining walls are just not that expensive. 10 foot, 11 foot are kind of getting up there. That's a 940, that's a 9. So this is like a 4 foot, 3 foot, you know, that's not bad. You got, and then this is, let's see, 940, you got 932. So this is 8 foot, 7 foot, 6 foot. And again, I'm looking at where the contour is down below to determine how high this is, right? So whenever the next contour hits is when it drops. 5 foot, 4 foot, 3 foot, 2 foot. So not bad, and it'll just blend into nothing, right? So, all right. Now, yeah, so I think basically that works. This is where maybe we price out the retaining wall to determine if it makes sense or not. I would love to put this in like a 3D kind of deal, like a rendering, so you can see what does that look like, you know, because what are some things we could do? Well, we could lower the whole house. Like imagine if you just took the whole house and dropped it, I'll exaggerate, but 4 feet. So if you did that and you kept it in the same spot, all of these retaining walls would be 4 feet lower. But I think what would happen is you'd be coming up this hill and then you'd look like it's down in a hole, you know, sort of thing. So I don't think I'd really want to do it. We could also bring this home and put it over here, which you and Justin had talked about. So it'd be interesting to see doing that if we just pushed it all over here, because there's a lot of meat to this home, like in this spot. And maybe we try to make this spot be here, right? And if we did that, now I would still try to line up the hill going down with that as opposed to the curve, you know? So I think maybe the next thing to do is to push it. But then the problem is, if you take it and you move it this way, then this becomes bigger. So that's where the trade-offs happen. There's a lot of retaining wall here. If we moved it this way, this retaining wall would get lower, but by definition, this retaining wall would get bigger. So usually the retaining walls end up being the same. It's just sometimes a 6 foot and a 6 foot retaining wall might be better than a no retaining wall and an 11-foot retaining wall, right? If you kind of want to do it. Also depends on where the trees are, and like, now it looks like they're scattered everywhere, so that doesn't jump out at me. But this might be something to see like on site, you know, get it staked, take a look at it and just see, okay, is there one spectacular oak tree somewhere that we just want to save or something like that? You know, but now we kind of know in general how it's going to look.